Hello everyone. Now I am going to explain you about a Gauss's law and proof of that Gauss's law. So coming to the statement of that Gauss's law is the net flux passing through any closed surface that should be equal to the charge enclosed by that path. That is, the net flux is psi that should be equal to the charge enclosed by that surface. So means you have to consider any arbitrary surface in that, so the total net flux passing through the closed surface that should be equal to the total charge in that surface. Okay, so coming to the proof of that Gauss law, here I am considering one sphere. In that sphere I am placing a point charge at the center of the origin. To find out that electric flux density, I am considering one more imaginary surface, so which is the dotted one. So imaginary surface, here I am considering this imaginary sphere. This is called as a Gaussian surface. Okay, this point charge is going to make a radius of r, and to find out the electric field intensity, I am considering one differential surface over this. So that is called as a differential surface ds. So this ds is normal to this unit vector an. So this ds is normal to the surface and normal to the unit vector ar. Therefore this ds becomes ds dot an. So it is normal, it is going to make an angle of 0. Generally it is a dot product of it. So you will get a ds into an into cos 0. So you will get a term of ds into an. So here, to find out the electric field intensity, first of all I am writing the electric field intensity of a point charge. E is equal to q by 4 pi epsilon naught into r square into ar. So from this one I am writing the electric flux density. That flux density is d bar, which is equal to epsilon naught into E. Simply substitute the E value here. Therefore d is equal to epsilon naught into q by 4 pi epsilon naught into r square into ar. So from this one I am writing the flux density d is equal to q by 4 pi r square into ar. Okay, so here I am applying a dot product with respect to the ds on the both sides. Okay, so therefore d dot ds, that should be equal to the q by 4 pi r square into ar into ds. But here we know this ds is nothing but what? Ds into an. Simply write that ds here. So you will get d dot ds is equal to q by 4 pi r square into ar into ds into an. Okay, this an is nothing but here normal to the unit vector, that should be equal to your unit vector ar. Okay, therefore d dot ds becomes q by 4 pi r square into ds into ar into ar. So here the dot product of two like vectors is 1. Therefore the term d dot ds is equal to q by 4 pi r square into ds. So here I am applying a surface integral on the both sides. So this is the surface integral. So this 0 indicates the closed surface. So the closed surface of the d dot ds, that should be equal to the, here q by 4 pi r square is a constant term. So with respect to the ds, so I am writing it as outside. Therefore surface integral of d dot ds is equal to q by 4 pi r square with the surface integral of ds. So by integrating this we will get a term s, that should be equal to the sphere of the area. So that is 4 pi r square. So by cancel outing this we are getting the surface integral of d dot ds, that should be equal to the charge enclosed by that part. So this should be equal to the net flux. Therefore the net flux passing through any closed surface, that should be equal to the charge enclosed by that path. Okay, this is the proof of Gauss's law. Thank you.